Alright, so here we are with transformations, which we're going to talk today about reflections, which are symmetric on the x or y axis. So, here we go. So taking a look at this equation here, again, lots of things happening, but we have kind of checked out part K here, which was moving something up or down. H, that letter, was talking about something moving left or right. And now today we're going to talk a little bit about some parts of A and B. So if you take a look at A, when A is negative, the function is actually symmetric to the x-axis. So just thinking about how that works, if we have an original equation here, if we're going to be symmetric to the x-axis, that's this one here, you're going to have this reflection down here. Okay, and so again, when A is negative, it's the x-axis that you're going to reflect across. The opposite is true for the other one, so if you look at the B value that might be inside next to the x, you're going to have this original equation that would then flip over the y-axis, which is, oh, I need a blue. Here's your y-axis, and then it would flip over to be here, like a mirror image. Okay? So again, that's when B is negative, you go across the y-axis. Alright, ultimately what I like to think of it as, especially if you look at it here, what we're trying to do is A is negative, and f of x is actually y, right? So all we're saying is that all of the y values have become negative. Okay, so that's what happens when A is negative, all of the y values become negative. This next one, if we think about it, it's actually when all of the x values become negative. And so again, if you think of how that is image-wise, instead of being over here on the x-axis where they're positive, you'd be over here where they're all negative. Okay, and so really anytime that I do this, I just think y's are all negative or x's are all negative. Alright, so let's take a look at this one here. Notice it's saying that we're reflecting on the x-axis, so looking back, that means that our y's are all negative. And that it flips on the x-axis. Alright, so if we're going to flip on the x-axis, this is a terrible picture for that because I don't have enough pieces, but we will flip as much as we can. So this is your x-axis, and again, all of our y's are negative, and this is your y column. So instead of -3, 9, it's -3, -9, and -2, -4. So all of these, oh, except 0, because 0 can't really be negative, all become negative. And so officially, you're still at 0, 0, right? That can't be negative. But we're going to have these pieces. And then 1, 2, 3, 4, this piece. And so it is going to be reflected on that x-axis. So we've looked at the table, how it changes. We've looked at the visual, how it changes. And so the only thing that we haven't changed yet is this piece here. So remember that in order to get our new equation, we needed to take the original f of x and put that -1 or that negative a out front. So how do we write that? That means -1 times our f of x, which is x squared. So writing it a little easier to look at, we just have -x squared. If there were any other pieces in that function, we would have distributed that negative into it, but of course there's only the one piece, so we could only make that negative. You'll also notice that there's a difference between this and what we actually have, okay? Because if it's this, then actually if you look back here, right, your negative is inside, and so that means that we've actually flipped it across the y-axis instead. So let's not put parentheses in there unless we need them. Alright, so again, how do you change the table? All of the y's become negative. How do you change the image? It becomes a mirror on the x-axis. And how do you change the equation? Everything is its opposite sign. So it was originally positive, but now it's negative in the answer. Alright, then we have our second example, which is now going to reflect on the y-axis. And so that means that all of the x's are negative. And of course when we say negative, we also mean opposite, because if there already is a negative, then you would need to make it positive. Negative negative is positive. And if the x's are negative, again, the idea is that this has become the mirror, or the place that it's flipped, because it's the y-axis. So, without just doing it by looks, we can go through and change each of these pieces. So instead of negative 2, you're going to have a positive 2 as your x. Instead of a negative 1, you're going to have a positive 1. 0, of course, isn't negative or positive, so it stays 0. 1 is going to become negative 1, and 2 is going to become negative 2. So rather than visually doing it, if we graph, we're going to have 2, negative 8, so over 2, down 8. Alright, then we have 1, negative 5. 0, negative 2, so they do share that because it's on the mirror, so it wouldn't move. And then we have negative 1, 1, and then negative 2, 4. And so you kind of make your little X visual here. Whoa, that is a really straight, non-wobbly line. Okay. So, let me see, anything else? Alright, so we've got our table, we've got our image, and now we're actually going to do it for the equation. So, instead of just f of x, we're going to put in a negative b, or a negative number inside for our x. And so officially that means that we are going to take 3, but then we are going to, instead of x, write negative x. And then we're going to simplify if we can, because 3 times negative x is not really how we write that. We would instead write it as a negative outside, 3, and then an x. But then notice that the minus 2 didn't change, because of course the intercept was the same. So, here is our new equation that flipped across the y-axis, so by making the x's negative. So again, the idea is opposites. If you're flipping across the y-axis, the x's make negative. If you're going across the x-axis, the y's are negative. Alright, so that's transformations and symmetry.